going to talk here to the more techie of you all, the one who actually code, and explain a problem that is often oversaw, which is secrets in source code. Just to give a bit of an explanation what secrets are elements that tie together the different building blocks of software application in modern development. So just a basic API key, for example, AWS keys are a common object called secrets. So just to set the scene. And why these secrets are really powerful for attackers to use for their initial access or lateral movements is because once they get access to your secrets, if you put them in code, their authentication is genuine. So it's very difficult to identify if the secrets, the API key they use is coming from a malicious actor or a genuine actor. So it's a very easy way for them to get either initial access to systems or then to use them in lateral movements and escalate their privilege. Secrets are actually used in everywhere in the software development lifecycle. They're used by developers in source code. They're used in CIs, in packages, in Docker images. They're used to deploy and run in infrastructure as code too. And they're even sometimes shared in different places to monitor where you monitor your code. So they're used everywhere, but it's not because they're used everywhere that they should be appearing hard-coded. There are ways to manage them through secrets management approaches or techniques, but often they get exposed in different ways. And you could say, yeah, a normal developer should not put secrets in hard-coded. Everyone knows that, but in fact, it happens very often. First, it could happen because secrets are committed for testing purposes. The coding is done. The developer puts the secrets for testing and then says, okay, I'll remove that later in my next commit. And they do. They remove it into the code, the latest version of the code. But unfortunately, Git has a big memory and nothing disappears. If you have a secret in a previous version of your code, it's still there in your Git history. And once an attacker get access to your code, they get access to the latest version, but they also can get access to a previous version and to version with your secrets. One of the common mistakes that is done too is when private repositories are made public, either by a mistake, and it happens more often than we think, or because they're open sourced. But then you open source you open source your latest version of the code, you check it, you've done code reviews, but you forgot that some secrets were buried in the history. But secrets detectors, they don't forget that. They can get access to your history of code and therefore get access to your secrets. You can have secrets also in logs or generated files, and in the CI, it happens often. Or sensitive files can be also included in some repositories. Or some accident happen. I will give you a couple of examples of attacks that use that type of accidentally code push in a wrong repository, repository that was in fact open sourced, or public. So you may have seen a lot of recent stories where secrets and source code leaks made it to the headlines. You have, of course, some lapsus at the lapsus group who used quite a bit of secrets to access some of the big companies they broke into, Microsoft being one. There has been stories around also the Twitch leak. A lot of time secrets are involved in one or another way, either for the initial access or, as I was explaining before, for lateral movement within code. At GitGuardian, we look at the public GitHub and we analyze overall the code that is published there, and we generate a report every year, which is called the State of Secrets Sprawl. And this year we analyzed 1 billion commits, which is more than last year, of course, because code is getting more and more out there. But in fact, even if we have scanned more code, the growth of the number of secrets we detected, which is now at 10 million, which is a big number, increased more than the actual volume of code. The problem is that we are using more and more secrets, as I was explaining, when developing code, because the modern development is increasing overall, and people are plugging objects with objects and using a lot of time secrets to do so. And mistakes are happening. And even if everyone knows we should not put secrets in source code, it happens so often that it goes to 10 million new secrets detected last year. If you see the reports we did, we did a report on 3 years now, and we started detecting 3 million secrets, 6 million, and now 10. And basically, it says that 1 author out of 10 exposes secrets. So it's not just the junior developer. It's basically anyone can make that type of mistake. And basically what happens, and this is the point of this presentation, is that why is it a problem? Well, it's a problem because attackers use open source tools like Trufflehog or GitLeaks, or we have plenty of solutions such as these for offensive purposes. They run the secret scanning on code, on public code, and they're trying to find these secrets that are low-hanging fruit for them to initiate access or move laterally. And I gave you here a couple of examples in recent breaches. I mean, one of the biggest one was the Uber breach in September, where basically the attackers got access to the hard-coded admin credential to Ticketic, which is in fact the access management platform, which is basically having the key to the vault. And as you can imagine, one secret giving access to all secrets, they were able to move laterally in all system from Uber and basically get access to everything, which is exactly what anyone doesn't want to happen. A couple of other examples, Circle CI, same stuff. The access token was of GitHub was basically accessed, and then the attackers were able to get to Circle CI systems. So it's a commonality, and it's a low-hanging fruit for any offensive action to use secrets at some point in the attack. So here, a couple of examples where I explain how it works. So for Uber, for example, as I said, it was one exposed secret, but it was, the worst of all. It was the one that gave access to the privileged access management system. And what happened is then once the attacker got access through a credential access through spamming of 2FA, he got access to this Ticketic key, and then he initially accessed the VPN and then scanned the Uber infrastructure, found a PowerShell script in which the secrets was hard-coded. And with that, he got access to everything. And you see the list of systems: AWS, Google Drive, Slack, SentinelOne, HackerOne, everything was accessed at that moment. Another example, back to what I was saying before, when basically we call it hitting the wrong button, but basically a lot of companies are using subcontractors, but it can happen to an employee also, where some source code was uploaded, but it was uploaded to GitHub, public GitHub by mistake. And this code was actually contained a hard-coded credential which gave access to customer data, and it was there for 5 years. in public GitHub until it was detected by, it was there for 5 years, but nobody knows if it was accessed during that time, because it could have been accessed many times. After 5 years, Toyota detected that it was there. And this is also a common thing, as I was saying, that private code can be made public by mistake, and it's going public with everything it contains, including vulnerabilities such as secrets, for example. A third example, it's a bit older, but it's a massive one in terms of secrets usage, is basically a key pass was hard-coded and was available into a Docker image. And the issue here is that CodeCov is actually used by many companies in their software development lifecycle. And when you get access, this is typically what we call a software supply chain attack, because once you get access to one system, you can spread into the supply chain. The supply chain being all the components that company use in their software development lifecycle. And this is some kind of attack that happened more and more because companies use many components, including many subsystems, sub-software. And if this software get hacked, basically they could have hacked components in their own supply chain. In the case of CodeCov, there was more than 20,000 other companies that were accessed through the hacking of the CodeCov component. So the way I'm just going to finish the presentation explaining how it works. Basically, there are different ways you could get to GitHub and find all these secrets, and they use different techniques as dorking and that type of things. Basically, they are searching it with powerful searches. They're searching access keys, they have different ways of finding them. Some examples here of dorking capacities. And basically what they do is they also look at different events that happen on GitHub. So typically public events. So when when code is pushed to public, this is a moment where hackers are on the look, because they think that at this moment they might get access to code that was private and that goes public. And if it goes public by mistake, as I was explaining, then of course it may contain some vulnerabilities that they can leverage. Hackers either target specific victims. So basically then they are looking at all the GitHub environment attached to this specific victim or company, looking at, the different GitHub bio of their developers, the code or the email domain and everything. And then they try to scan the Git history with different tools. As I mentioned, they can use different type of tools like Trufflehog or Git Secrets in a way to basically search. They can also, so this is looking at a specific victim. They can also work in a more spray and pray approach. And this is usually more into an economy of selling credentials. So basically they scan GitHub on a large scale, trying to find some specific keys. So for example, the AWS keys are the one that are really interesting for crypto miners, for example, and they're then selling them on the black market. And there is a real economy. If you read the report I was mentioning, the State of Secrets Sprawl, we work with a company specialized into that type of research, and they explain how there is a real economy of the dark web around credentials and what you can find there. So this is another technique that hackers use to find credentials. So the way basically to protect your code once and for all is basically try to use short-lived credentials. So when you can rotate regularly, because then, of course, if a key that has been rotated is on the public space, well, it's not usable anymore. So that's one way. You should use tools also to prevent secrets entering your Git repositories. So there are different type of tools. Of course, GitGuardian is one of them, and it's. I just remind everyone that it's free for individual developers and teams smaller than 25. So if you want to test it, use it. There are also open source tools that I mentioned earlier. They can help you maintain a good code hygiene and making sure no secrets make it to your code. And then, of course, the best is to add automated secrets detection if you're working on larger projects or if you have larger development teams. As I mentioned, the more code you produce, the riskier it is that secrets end up in your code. We work with company and when we start auditing their code, when we do proof of concept, we usually find a lot of secrets, and it's not because your company is I would say security aware that you don't have this problem. So for example, we audited some code that was made public. I spoke about the Lapsus group when they made public the code of Microsoft. For example, Microsoft is very secure aware, and still we found hundreds of secrets in the code that was made public. So I think no company is protected around this until they actually make sure through automation that no secrets make it to their code. So that's it for today. I hope it was clear enough. And if you have any question, of course, you can come back to me or come back to GitGuardian. I've put a couple of links that are here. You can visit our blog. We have a lot of explanation if you are a junior developer, to help you maintain and rotate your keys and explain what to do if you actually put secrets in the public GitHub or anywhere, even in your private code. Any secrets that is hard-coded should be considered in danger in a way, and should be rotated. So feel free to look at videos on our YouTube channels or go to our learning center to learn more about this. Thank you very much.
That moment when you forget to unmute yourself. Thank you so much for this great presentation, for the perfect timing, and for providing the resources. And we have a couple of questions, and let's take perhaps one. We still have 1 minute. What role does automation play in identifying the mitigating exposed credential in source code?
So the automation basically will tell you if you have secrets, and then will help you organize the as you say, the mitigation and the cleaning of the code. So basically, in large companies with a lot of developers, when a secret is in the open, in the source code, it's not so easy to do the remediation, because code can be used in different places, and the secrets can be, opening to an application that is actually live, for example. And if you rotate the secrets, you could put everything, at risk. So secrets detection and remediation solution help on both sides, because detection is one piece of the problem, but remediation is maybe the largest and most difficult part, because you need to remediate in group, collaborating, making sure that you don't break your systems.
Thank you. Thank you so much, Carole. Thanks for this insightful presentation, for being with us, for everything that you do at GitGuardian.
Thank you.
And perhaps if people have more questions or would like to reach out or watching this later,
Yeah, they can just go on our website or contact at gitguardian.com, or, you know, on any of our YouTube channel. We have Twitter, LinkedIn, wherever. We're
reach
there.
out.
Yeah,
Just
exactly.
reach out. Yeah,
Yeah.
don't hesitate to reach out. Thank you so
Yeah.
much, and have a good
Yeah,
day.
thanks a lot. Thanks, Ivo. Yes, check the booth. Thanks. Bye.
Bye.